grade 10s. How are you guys doing today? Welcome to our third lesson in this series of video lessons. Today we are going to be looking at group 7 elements. We're going to be looking at group 7 elements. In the previous lesson, our lesson number 2, we looked at effectively lesson 1 and 2. We looked at group 1 elements. We looked at the physical and chemical properties of the group 1 elements, and then we also looked at the reactions which group 1 elements take part in. So we are now moving on from the group 1 elements, and we are now moving on to the group 7 elements. So I have decided to divide this topic on group 7 elements into 2 lessons. So we'll have this first part, and then again lesson number 4 will again be on group 7 elements. Okay, so let's get into it. So what are the objectives for today's lesson? For today's lesson, we want to be able by the end of the lesson to outline the physical and chemical properties of group 7 elements. The physical and chemical properties of group 7 elements. We should also be able to describe the reactivity of these group 7 elements. By the end of this lesson, we should be able to know, okay, so which one is the most reactive, why is it the most reactive, and I've also decided to really include a part on electronegativity in this lesson, right? We will also want to look at electronegativity. I will just try to give it to you guys briefly and explain what the concept of electronegativity is all about, right? So you guys at this moment, as always, you can just pause the video for a couple of minutes, just look at the objectives and compose yourself. Okay, welcome back, guys. So I hope you've had a chance to look at the objectives of this lesson. Right, so we said we are looking at group 7 elements. We are looking at group 7 elements which are also known as halogens. They are also known as halogens. And when we are looking at our periodic table and we have these group 7 elements, if you are looking at your periodic table, can you just try to identify? I'm sure by now you've looked at the elements starting from the one at the top. Just try to identify the names of the elements which you have in group 7. I have drawn one of them on the board here, the board structure of the first one. The first one is fluorine, right? So we have the element fluorine, and the number of electrons that it has in the outermost shell, because remember, groups are determined by the number of electrons that are in the outermost shell. The moment you know the number of electrons that are in the outermost shell, you can tell which group the atom is in or the element is in. So if we look at fluorine here, it has 2 electrons in the first shell. The first shell, remember, can only be occupied by a maximum of 2 electrons. But its outer shell is having 1, 2, I hope this one is visible, it's again an electron, 1, 2, 3, 4, 5, 6, 7. It has 7 electrons in its outermost shell. That is a characteristic feature of all group 7 elements, whether it's fluorine, whether it's chlorine, whether it's bromine, iodine, or acetine. They all have 7 electrons in their outermost shell. Okay, so that's a point to remember. Yes, Jane, Victoria, guys, please remember this. Devin, Ferrimue, guys, 7 electrons in the outermost shell. Right, so when we're still looking at what other physical properties now do they have, so these elements which are in group 7, we would say, we'll look at, let's say, their densities. Right, so in terms of their density, they have densities which increase, right? Their densities increase as you go down the group. Their densities increase as you go down the group. Remember, when we are looking at individual groups, we are comparing the elements that are in those specific groups. So if we are in group 7, we are comparing what fluorine looks like in relation to iodine, in relation to chlorine. So we would say the density, if fluorine is the least dense of the group 7 elements, because density increases as you go down the group, which means the groups which you will find, the elements which you will find lower down the group, you can also use compare it with the mass numbers of those elements, right? You'll find that they are much bigger, they are much heavier, and therefore they are much denser than the element fluorine. Okay, what else do we have in terms of physical properties? So in this lesson, I will look at some of the physical properties and the chemical properties, and in the fourth lesson, again, I will delve into some of them again. Right, so there are melting points and boiling points increase, yes, they increase as you go down the group. The MP and the BP, the melting point and the boiling point increase as you go down the group. This has something to do with what are known as temporary dipoles, but effectively for you guys, it's just an issue of how the number of electrons are increasing, right? I'll just try to explain it a bit further in the next lesson, but it has something to do with what we call temporary dipoles, which come as a result of an increase in the number of electrons. Because if you look at fluorine, it only has 9 electrons, but then if you were to go down to chlorine has 17, right? Chlorine has 287, it has 17. If you go to iodine, if you go to bromine, they have many more electrons. And this affects the melting point and the boiling point of these group 7 elements. Right, let us also look at a concept known as electronegativity. Electronegativity. Let me just write the definition of the term electronegativity on the board for you guys. Okay, so we are looking at the concept of electronegativity, and electronegativity refers to the ability of an atom to pull electrons towards itself. Right, the ability of an atom to pull a pair of shared electrons towards itself. If you look at covalent bonding, right? If you look at covalent bonding and we look at bonds such as that when we have hydrogen, and let's say when it reacts with fluorine and they form hydrogen fluoride. If they form hydrogen fluoride, because fluorine, these group 7 elements are highly electronegative, and fluorine is the most electronegative of these group 7 elements, right? So when you look at the concept of electronegativity being the ability of an atom to pull a pair of shared electrons towards itself, right? We say in group 7, fluorine is the most electronegative. Right. So when we are looking at that concept, we give the example of saying, let's look at maybe if there was a bond between hydrogen and fluorine. Okay, hydrogen and fluorine. You would have a pair of electrons, because remember, these are group 7 elements, and they need to obtain one more electron for them to have a full outer shell, because they need to have 8 electrons in the outermost shell for them to be completely stable. So they need to gain one more electron. So if there was going to be a covalent bond, right, and let's say hydrogen comes and bonds here, right, but it brings its dot here, right. So this is now hydrogen fluoride, okay, hydrogen fluoride. This pair of shared electrons, would actually be pulled closer, right? It would be pulled closer to fluorine than it would be to the nucleus of hydrogen, because fluorine is much more electronegative than hydrogen. So the shared pair of electrons will be pulled closer to fluorine. So electronegativity, the ability of an atom to pull a pair of shared electrons towards itself. And when we are in group 7, the most electronegative atom that is in there is fluorine, right? And the electronegativity decreases as you go down the group. So you can just look at it's just a simple diagram. It's just basically a simple diagram showing you hydrogen fluoride, okay? Between hydrogen and fluorine, and the electrons, the pair of electrons would be drawn closer to fluorine because it is more electronegative. Right, so that is that on the concept of electronegativity. We're just touching on it It's just a base explanation, right? Another property of these group 7 atoms, right, is that they are found in nature as they exist as diatomic molecules, right? They are always diatomic molecules. So if you find them in nature, you will find that it would be F2, or it would be Cl2, or it would be Br2, right? Or it would be Br2. They exist as diatomic molecules, Cl2, Br2, F2, right? Especially for fluorine and chlorine being gases. Fluorine and chlorine are gases, and then bromine is a non-metal, right? Bromine is a non-metal, and actually there is a point that then comes in to say bromine is actually the only liquid non-metal at RTP, at room temperature and pressure. All the other non-metals are actually gases, right? All the other non-metals are actually gases, or they are solids, right? So if you think of sulfur, it's a solid. If you think of carbon, it will be a solid. If you think of oxygen, it's a gas, right? But when you have bromine, it is the only liquid non-metal at room temperature and pressure. Okay, so these group 7 elements, because of their position in the periodic table, far left, right? Is it far left or is it far right? They are all non-metals. Okay, they are all non-metals. Fluorine all the way down to iodine. Iodine is a non-metal also, even though it's a solid, right? Even though it's a solid, but it's a solid non-metal. Okay, same also for acetine. All of the group 7 elements are non-metals, and they form molecular compounds, right? They form molecular compounds, these group 7 elements, these halogens. They form molecular compounds such as this one, which we have here, which is hydrogen fluoride. They also form the common one, which we know, which would be HCl, which would be HCl, right? HCl. They also form, these are covalent compounds, but they can also form ionic compounds. They can also react with metals to form ionic compounds, such as potassium chloride, right? But when we then look at the ionic compounds, remember we're saying these ones would be covalent compounds, right? These ones would be covalent compounds. Or if you think of, you remember that one which we always mentioned in grade 9 when we were talking about damaging the ozone layer, and we would refer to chlorofluorocarbons. Chlorofluorocarbons, CFCs, massive compound, CFCs, chlorofluorocarbons. That's also another type of a compound that is formed by the presence of those group 7 halogens, chlorofluorocarbons, CFCs, right? Maybe you want them to be CLFCs, but we'll just say CFCs, chlorofluorocarbons. Then when they react with metals, these group 7 elements, they react with metals, and they usually, or they always gain an electron that is donated by either the group 1 metal, or the group 2 metal, or the group 3 metal. Whenever they receive these electrons, right, like chlorine, if it is to react with potassium, and let me just draw quickly. Okay, so like I was saying, they can also react with metals, these group 7 halogens, these group 7 atoms. They can also react with metals to form ionic compounds, such as this one where you have potassium reacting with fluorine to produce potassium fluoride. And in the ionic compound, how the ionic bonding takes place, you have potassium. Observe how I have only drawn the outermost shell, because when we are drawing these, when these reactions are taking place, it's only the electrons in the outermost shell that take part. So for potassium, there is obviously a first shell with 2, a second shell with 8, but I have only drawn the third and final shell, that is 1 electron. For fluorine, I have only drawn as well the outermost shell. I haven't drawn the first one that has 2 electrons, right? I hope you recall this. So when we say potassium plus fluorine, because this is an ionic bond, the metal donates an electron to the non-metal. Because potassium wants to lose this electron, fluorine wants to gain 1 electron. Potassium then, after donating its 1 electron, then is now left with an outer shell that has 8 electrons with a charge of +1. Fluorine has now gained 1 electron and now has a charge of -1, which brings us to the key point, which then says atoms in group 7 form ions with a charge of -1. They form ions with a charge of -1, and they are known as, like this one, it will be known as the fluoride. This is the fluoride ion. That is the fluoride ion. So we can have the fluoride ion, we can have the chloride ion, okay, iodide, bromide. So when they gain 1 electron, and they now have achieved a full outer shell, they then become known as halides, right? They become known as halides. Okay, so we also know that the reactivity now of the group 7 elements, which one do you think is the most reactive? Which one do you think is the most reactive? I think before I just finish this one, let's just have you guys pause the video so that you can just try and draw an ionic bond for magnesium and chlorine. For magnesium and chlorine, and you will show me the answers in our next meeting. Okay, so I hope you guys were able to draw the structure for the ionic bonding between magnesium and chlorine to form magnesium chloride, and you will show me during the WhatsApp lesson. Okay, so we were now talking about reactivity and how reactivity decreases effectively. Reactivity decreases as you go down the group. The most reactive elements, right? The most reactive elements or atoms in group 7, or the most reactive atom, is this one, fluorine. That is a highly reactive atom. Okay, that is a highly reactive atom. Why is it highly reactive? It is highly reactive because you see that fluorine only has the first shell, this one, with 2 electrons, then its second shell, let them all be dots. If they are dots, then let all of them be dots. So its nucleus has the ability, it has the pulling power, it has a very strong pulling power, right? Fluorine has a very strong pulling power, which is why we talked about the concept of electronegativity. And that allows it to be able to pull electrons from other compounds and from other elements. So if fluorine is anywhere in the neighborhood of potassium, if potassium is moving just past fluorine, fluorine will just say, can I please have that electron? And it will pull it, right? That's the pulling power that it has, which makes it the most reactive element or the most reactive atom in group 7. And then this reactivity trends and goes down as you move down the group. Right? So electronegativity increases or decreases as you go down the group. Reactivity decreases as you go down the group. But melting point and boiling point increase as you go down the group. Reactivity decreases down the group, but melting point increases down the group. Okay, and that also affects why fluorine is a gas, right? Bromine is a liquid, and iodine is a solid. I'll explain that as well in the fourth lesson. Right. So we have looked at the reactivity. Okay. So in the next lesson, I will show how the reactivity, why these electrons or why these atoms which are more reactive, such as fluorine and chlorine, are then able to then take part in displacement reactions. Right, so I've left the concept of displacement reactions and also a few physical properties. I have left them for the second lesson. So I will touch on that, and I will also write several equations using these group 7 elements. Right, using these group 7 elements. So in this lesson, we have managed to outline some of the physical and chemical properties. The reactivity, we've just talked about it now. The reactivity decreases as you go down the group. Electronegativity, I hope you wrote it down somewhere and you now have the clear definition of what electronegativity is. You encounter this word several times in the course of your chemistry studies, right? So as always, guys, you have been great, you have been wonderful. Thank you very much. This is your teacher, Marshall A.C. Candiado.